All right, and Jackie's coming in. All right. All right, I'll fix both of those. Okay. So one of the things I wanted to talk to you about with your test, one problem I think I forgot to put on there was interval notation, which isn't too difficult, but having looked at the forums and the posts, and there was a few people that were a little confused about that, so I thought, okay, we better just talk about it. So, okay. That review is up there under test one items. I think I put a recording of the class the other day up there, and so it's all up there. So when you're working with interval notation, I think people get confused about inequalities, and I want to make sure you got inequalities down because, you know, it's time, right? If we don't, all right, so there's less than. Somebody else coming in. Yeah, Matthew, I see you. I'll fix your attendance. Get there. Okay. Less than looks like this, and greater than looks like this. All right. The way that I remember, if I kind of turn the L on its side, less than, you can kind of turn it about 45 degrees and it becomes an L, right? The greater than I can't really turn. So, I mean, I know which is which just by the less than, it kind of looks like a tilted L. So when you're faced with an inequality, something like x is less than 2, and you want to do interval notation, all right? First thing to keep in mind, all right, just like in second grade, the alligator opens to the bigger number. That's another way to think about it. So when I look at something like this, the alligator is opening to the 2. Because the alligator eats the bigger number. Hold on, you need to pull that up. Oh, Matt, I saw you. I saw you.
I was trying to join on my phone, but the meeting ID said that I needed a password. So I came back.
It might be the joining on the phone part that's a problem.
Oh, yeah. So I was here like.
I don't think I set them up for the phone. I mean, I don't know, but yeah, okay. With the phone, there is a meeting ID, but I don't. Yeah, I mean, you can get to. You go to Zoom and get it, but it's not. Yeah, I don't send the password. On a phone that can happen. Yeah. So you really want to be on a computer.
Am I good for attendance?
Yeah, you're good. I got you. I wrote your name down so I come in. Okay.
Thank you.
Thank you for checking. All right. So if the alligator opens to the 2 here, so that means that 2 is the biggest number, right? And one of the things I like to do is write a number line when you do interval notation, because here's 2, and I'm going, the numbers can only be up to 2, so we're going this way. All right. And one of the things with interval notation, you use a round bracket when you have less than or greater than, an open dot, or infinity. All those things require a round bracket next to it. You use a square bracket when you have those equal signs, right? All right. So in this case, because I don't have an equal sign, I see Sam coming in too. All right. Because I don't have an equal sign, I use a round bracket. All right. So, but what I want you, if you put it on a number line, you know, I put negative infinity on my number line, and I always read the numbers from left to right. So if I were to write this in interval notation, it'd be from negative infinity to 2, and that would be correct. All right. Writing from 2 to negative infinity, writing that backwards is a no-no. Okay. You always write it from smaller number to bigger number. So the negative infinity must come first. Okay. So that's some of the things I saw with you guys. So for example, if I wanted to write x is greater than or equal to 5 with interval notation, now how do I know the alligator opens to x? So that means that x is the bigger number, right? So x has to be bigger than 5, right? So on my number line, here's 5, and x has to be bigger, so that's that way, right? So here's infinity out here. So with interval notation, I'd go from 5 to infinity, like that. 5 has a square bracket because of the equals. Infinity is always round, okay? Always go from left to right when you do numbers, just like you read, all right? Now, there's 2 other types of inequalities you might see, which aren't too bad. This one is, I think, the easier one of the 2. Okay, so when you see this is what they call compound inequality. It says x is greater than 2 and less than 3. It's between 2 and 3. The inequalities should never open to the left. They should always open to the right. All right, when you open to the left, it doesn't say what you think it does. All right, it can only go this way. And basically, all I have to do is I know it starts at 2 and ends at 3. And because the equals, 3 is square and 2 is round, right? Now, sometimes you have 2 sets of intervals, and that happens, it will be written this way. X is less than 1 or x is greater than 5. that is never written in the form above. Because you can't write it like that. It doesn't mean that because it's got or, all right? And so basically, if I do this on a number line, here's 1 and here's 5, all right? If x is less than 1, we're going this way, right? And this is an open circle. If x is greater than 5, we're going from 5 up, all right? So what we have are 2 lines, all right? So because we have 2 lines, we have 2 intervals, so we're going to have 2 sets of interval notation, all right? So negative infinity. So the first interval goes from negative infinity to 1, right? And the second interval goes from 5 to infinity. And we have the word or in math is a union, right? Okay, and is intersect. So that's how you write that, okay? So you might see some interval notation. I want to make sure you guys are good. Any questions over interval notation? Okay. All right, so what we're going to do today is we're going to talk about, I'm going to go to 4.2 on page, I think it's 112. We're going to talk about some advanced type of factoring, all right? Now, you're not going to get tested on this, all right, because it's something you'll see in 1325. You will need some of these techniques in 1325. You don't only need them in 1324. So it's just something that we want to talk about, but it's not on your test. Your test is basic factoring, all right? So what you're seeing today really won't be on the test in here, okay? All right, so we're going to go to, I think it's page 112. Yeah, nope, yeah, factoring with use substitution. All right, so that's page 112. We're going to start here, and then we'll go back and talk about augmented matrices and simplex tableau. You guys are doing matrices right now. Are you multiplying them? Are you solving equations with them? You doing RREF? Huh?
No, multiplying matrices.
You're multiplying. Okay, so you've just started matrices, okay? So with the matrices, you're going to go from multiplying to solving equations, which isn't bad, just use your calculator, to what they call simplex tableau. So today I'm going to show you how to set up a simplex tableau problem. So when you get there, you'll go, oh yeah, there was something about that, okay? But it may not make sense. Well, it will make sense, but it's just, it's out of context because you haven't gotten there yet. So just be aware of that. All right, so, so we're going to talk about factoring with use substitution. So, you know, when you look at problems, one of the things I do when I look at factoring, 2 terms tells me it's probably a difference of squares. That's the a squared minus b squared. 3 terms tells me it's a quadratic of some kind. I mean, most likely it's going to be something I can factor. You know, in the real world, things don't factor, but in calculus, they always factor. So I'm thinking it's something I'm going to have to factor. So if you look at these examples, these are all quadratic type of expressions. They have 3 terms, and all 3 of these can be factored. We won't necessarily talk about all of them, but it's a possibility, all right? But the cue there is that I see 3 terms, all right? So we're going to talk about how to do that. All right. So one of the easier things for you guys, so you guys actually working on this yesterday with a 9th grader, because that's what they're doing in their algebra 2 right now. So and she struggled with this until we put U's in there. So you can do a little substitution to make it look better, all right? So when I tell you, when you have 3 terms, your best bet for you is the thing in the middle there, all right? So I'm going to let U be x squared. So what happens is that I'm going to square U. So U squared would be x squared squared, which using my exponents rules would be x to the 4th, right? So you see that by doing that, this guy right here is U squared, okay? So by substituting at U equals x squared, everywhere I see, so I'm going to replace x to the 4th with U squared, and then 5x squared with 5u, and then plus 6. So once I've made that substitution, now this looks a lot easier, right? Because it looks like a simple old quadratic, right? It's something I can factor, right? Which is what she does in her next step. So remember, she finds factors of 6 that add to 5, which would be 2 and 3. So she says she factors this u plus 3, u plus 2, right? So that's what we would usually do. So what's the difference is that we have u's, we have to go back to x's, we have to go back with what we started with. But we know what u is x squared. So everywhere I see u, I'm going to replace it with x squared. So that's what she's done here. She's replaced the u's with x squared. Okay. Now, yeah, let's talk about this. Now, one thing I want you to be aware of, sometimes things factor more than once. X squared plus 2 and x squared plus 3, they don't factor because they're sums of squares, right? But what if I did this? I'm gonna come over here and show you something that does factor more than once. If I did x to the 4th minus 81. Actually, let me, yeah, sorry. All right. So I know if I let u equals x squared, u squared is x to the 4th. So this becomes u squared minus 81. So I could factor that, right? Uh-oh, I need a different number. All right, I'm gonna change the 81. I'm gonna change it to, let me see, will that factor? No, I'm good. All right, I'm good. So this would factor, difference of squares would factor u minus 9, u plus 9. Right? But you know that u is x squared. So it's x squared minus 9, x squared plus 9. What you have to be aware of, sometimes after factoring something that's somewhat complicated like this, you can factor again, because if you look at x squared minus 9, that's another difference of squares, right? And you can factor that, right? You take the square root, so this is x minus 3, x plus 3. The sum of squares doesn't factor. So my point to you is be careful that when you get up into multiple layers like this, sometimes you can do a little more factoring. Okay, let's talk about mistakes. So what happens? All right, some things that you have to do. If you're going to do u substitution, you must substitute back to the original variable. You cannot end with u, you have to end with x. All right, you've got to go back. Be on the lookout for differences of squares. This is what we talked about right here. All right, remember that these can be factored further. So if I end up with x squared minus 16, I'm not done yet. Okay, so look for that. Now, look for the u substitution to factor. I'm looking for something squared plus a number times something else. So I'm always looking for what is that thing. So when you have parentheses, you see there's 3 terms here. So I'm going to let u be now the thing in parentheses. So I'm going to let u be x minus 3. Okay, so now I'm going to replace x minus 3 with u. So I have u squared minus 2u minus 3, just like that. And now it's so much easier, right? Now I'm going to warn you guys, you could have multiplied that whole thing out, like done FOIL and all that. It's a lot more work. All right, and you want to simplify your life. All right, so we're going to factor this. I need factors of -3 that add to -2. So tell me what they are.
-3 and 1.
Okay, good. -3 and 1. So remember, I just split the u up. So u minus 3 and u plus 1. So I factored it. Now my last step is, once I have it in terms of u, I've got to go back to x. Well, I know what u is. U is x minus 3. So I'm going to put that back into my expression. All right. So u is x minus 3. So it's x minus 3 minus 3 and x minus 3 plus 1. Right. So I end up with x minus 6. -3 and -3 is 6. -3 and 1 is -2. And now I'm factored. All right. And I'm back to x's. Okay. All right. Any questions about how I did that? You good? Or have I lost? You good? All right. Like I said, you won't see this on one of my tests. You might have to do it 1325. Okay. So let's try another one. All right. So if I want to factor this one, what am I going to let u be? You guys tell me. U equals what?
X minus 1.
Good. X minus 1. All right. So what I have here is 2 times u squared plus 5u plus 3, right? And now this is something that's a lot easier for me to factor. All right. So 2 times 3, I need factors of 6 that add to 5. So what would those be?
2 and 3.
Good. 2 and 3. All right. So because a leading term is not 1, I'm going to do my kill the common factor. I'm going to copy, and then I'm going to kill the common factor. So I'm going to copy the 2. So I have 2u and 2u. I'm going to write down the factors, +2 +3. And then I'm going to kill the common factor. So if I look at the first set, I can take a 2 out of there. So I just divide them both by 2. So I'm left with u + 1. The second set, there's no common factor. So we just leave it, right? So we're factored in terms of u. Now I got to go back and plug in what u is. U is x - 1. So I'm just going to take that and plug it in. Put it in parentheses if it gets complicated. So we'll show you that. So u is x - 1. So it's x - 1 + 1. Now 2 is multiplying x - 1. So you better put parentheses around it. Okay. And then I just got to simplify it. So -1 + 1, this is just x. And here I have distribute 2x - 2 + 3. Combine these guys. -2 + 3 is +1, and then we're done. Is that okay? Any questions about what I did? These are the harder factoring ones. Okay, so what we're going to do now is this looks really scary because of the fractions, but they're not really. I see an x and an x, and I see a 20. I see 3 terms as some kind of quadratic, right? So here's my hint for you. Is let u be whatever that is, the middle term there. So u is x to the 1/4. So let's figure out what u squared is. So u squared would be x to the 1/4 squared. All right, well, those are exponent rules. So I have a power to a power, I multiply them, right? That's my test on my test tomorrow. So 2 times 1/4, I could do it on a calculator, or I could just simply do it. It's x to the 2/4, so I just multiply the tops and the bottoms. It's x to the 1/2. So guess what? There's my u squared right there. Okay, so that substitution will work. All right, so x to the 1/2 is u squared, and then minus 9u plus 20. Once I have that substitution, I'm good, right? And now I can factor. Okay, I need factors of 20 that add to -9. So they would be what? Yeah, -4 and -5, they both need to be negative. So this factor is u minus 4, u minus 5. Okay. Now I just plug back in what u is. U I had was x to the 1/4. So it's x to the 1/4 minus 4. X to the 1/4 minus 5. Now there'll come a point where you're going to want to set those to 0 and solve them, but we're not doing it yet. Okay. All right, we good? All right, so I'm going to ask you guys, what do you think I should let you be in this next problem? I got 3 terms, so it's probably going to be quadratic. What do you think I should let you be? Good, yeah, x to the -1, right? Because u squared, if I square x to the -1, just multiply the exponent, I get x to the -2, which is this guy right here, right? So we're good. All right, so what I have is u squared plus 5u plus 6, right? And we just factored that like a second ago, right? So factors of 6 that add to 5 are 2 and 3. We just did that. U plus 2, u plus 3, all right? But again, you don't leave it in terms of u. You got to go back to x. So u is x to the -1. So put them back in. All right, and we are factored. could also write this x to the negative 1 means 1 over x, right? That's something I should know from your test. All right, we good? Eventually we'll solve them. We're not solving them yet. All right, any questions about what I'm doing? Okay, so I'm going to do a couple more examples because she kind of left off a couple things that you might see in MATH0324 that I want you to see. So I'm going to come over. I think I've got some room here. And we're going to look at two problems, all right? They're both kind of the same. What happens in calculus is often you take a derivative and you get negative exponents. And I want you to, when they all have negative exponents, there's a way to factor those. And I want you to see that. So I'm gonna do two problems for you. We're gonna look at this one. We're gonna see how to factor this. Okay, so what I want you to understand is you can factor something out when the bases are the same. So you see they both share the number x minus 4, right? In fact, if that bothers you, let's go ahead and let's let u be x minus 4, just to simplify it. So this would be 2u to the negative 9 plus x times u to the negative 10, right? Now I want to factor this. When you have negative exponents and you see that they both have u's in them, right? I'm going to take out a power of u. Here's the hint. Take out the most negative power of u. All right, so the most negative power is u to the negative 10. So that's what I'm going to factor out. So what I factor out, I divide by. I want you to see what this does for you. Okay, so in this first expression, you have u to the negative 9th over u to the negative 10th. Now that's, you subtract the exponents, right? So u to the negative 9th, I'm going to write it somewhere. Let's write it in green just so you see. So u to the negative 9th over u to the negative 10th. I subtract the exponents. So u to the negative 9 minus negative 10, right? So those two negatives together become a positive. So it's u to the negative 9 plus 10. Well, that's u to the first power, right? 10 minus 9 is 1. So this is just u to the first. So this is just u. So I have a 2u here. All right. So I combine these guys, right? Now, these guys, they just cancel because they're the same, right? So then I have plus x. All right. So I'm pretty well factored. I've just got to put u back in there. U is x minus 4. So it would be x minus 4 to the negative 10. Times 2 times x minus 4, right? Yeah, plus x. Now, if you'd like, you need to distribute here. So it's going to be 2x minus 8 plus x. The second would be 3x minus 8 times x minus 4 to the negative 10. So now you factored that thing, okay? So my hint for you, when you have x powers of x's with all exponents, negative exponents, or even fractions, pull out the most negative power of x you can, all right? So we're going to look at one more, and then we'll be done, just so you can kind of have a preview of this. Let's look, I'll give myself some space here. Let's say I want to factor this guy. 2x, 3x. Okay. That's a 1/2. I don't know if you guys can, this is a bad 1/2. All right. So I look at something like this with 3 terms, it looks like a quadratic, right? So I'm thinking, all right, what if I take out, and it's different from the other one we did because they have x in all of them. So I need to take out a power of x. The way that I do that is I find the most negative power of x. So the most negative power of x is x to the negative 1/2. That's what I'm going to take out. So I'm going to take out x to the negative 1/2. So what I take out, I divide by. So those just cancel, that's easy. Now, if I subtract the exponents, I have 3/2 minus negative 1/2. The two negatives become a positive. So I end up getting 4/2, which guess what? That works out to be 2. So this is 2x squared, the first term here. And if I do 1/2 minus a negative 1/2, I'm going to add them, I get 1. Okay, so this is just x to the first power. And those cancel, so I get -6. So by taking out the most negative power, what I've done now is I have something that I can work with. Okay, so when you have x's with weird fractions and take out the most negative power. Okay, so now I can factor it, right? So this is just straight factoring. I need factors of 2 times 6 is -12 that adds to -1. What would they be? I think I heard it. -4 and 3. Right, so it's multiplied to -12 and add to -1. All right, so I'm going to factor that. I'm going to do my kill the common factor. So I'm going to copy the 2 to the front, copy, write the factors down. And then I'm going to kill common factors. I can take a 2 out of here. So that becomes x minus 2. And this other guy I can't take anything out of. And there's my answer, okay? So these are things that you might see in calculus class, all right? And so that's why I want you to see them now, because you go, I knew there was something about, but I don't remember it. Go back, okay? All right, so that's your advanced factoring. Like I said, on your test, it'll be just the basic stuff. It'll be up to your 4.1, okay? You won't see it on the final either, so. All right, so what we're gonna do is we're gonna go up and we're gonna talk about section 4.2 up top, which I think starts on page 39. Okay, let me kind of, okay. Down there. So you're working with matrices right now, and there's a lot of things you can do with matrices. Or one's on a video. All right. Now, there's a program that you're going to need, or you're going to have to go to a website and use it. It's called Simplex Tableau. All right. And Simplex Tableau uses something called augmented matrices. All right. And in augmented matrices, we're going to set those up today so you can see how an augmented matrix is. All right. Simplex Tableau, you're not going to have a feeling for why it works. You're going to have to take it on faith it works. Okay. She's going to say, here it is, plug it in this calculator and voila. Okay. So what Simplex Tableau is, you're trying to maximize something subject to some constraints. So what I mean by that, usually as a business, I want to maximize my profit. You know, if I'm making Xboxes and PlayStations, you know, I'm going to make so many of this and so many of that. And that whatever I make will maximize my profit. But I have things called constraints, subject to limitations. You know, with the Xbox, I only have so many displays available. I only have so much money for electronic components. I only have so many employees. You know, whatever my constraints are, there are limitations on what I can make because I just don't have everything I need. You know, if I'm going to make a cake and I need eggs, flour, and sugar, you know, if I have 5 cups of sugar available, that's a constraint. That's all I've got. All right, when I run out, I'm out. So the constraints are what we call their inequalities, but we'll get to that. So right now, I just want to show you how to set up an augmented matrix. Okay, so an augmented matrix is different from a regular matrix. Have you guys been doing on REF? Because you've been doing augmented matrices if you're doing REF. Solving systems on the calculator? No idea. Okay, all right. So we're gonna set up. All right. So what I have here is a system of equations. X, Y, and Z and the answers. All right. An augmented matrix contains not just the coefficients of the equations, but the answers. So if you look at this, for every coefficient, she puts a number in the matrix. So 1, -2, 3. See how she puts them in there? And then she puts the answer in there. 72. The second one, they're all ones, 1, 1, 1, and 4. And the third row, -3, 22, -2, and -10. So that's how we set up a matrix. We just put the coefficients right. It has to be in order X, Y, Z answer. All right. The thing, they put a bar here. That bar is it's not really necessary. It's just like a convention. It's just showing you that 72, 4, and -10 are the answers. Okay. All right. So But what I want you to understand, the first column were all the X's, this is the Y's, this is the Z's, and this is the answers, okay? So that's what an augmented matrix is. All right. All right, and she talks about all that. All right, so to create an augmented matrix, X, Y, and Z have to be lined up with the answers. So, and this one's all lined up already. So I can pretty much just make a matrix. If I read across the row, I get 3, 1, -2, and 2. The second row is 1, -2, 1, 3. The third row is -1, -1, 3, and 6. If you like, you can put a bar there. You don't need it. Okay. So you're just making a matrix of all the coefficients of the equation in alphabetical order, all the answers. Okay. So to make an augmented matrix correctly, it should be in alphabetical order, all the X, Y's, and Z's, all in the same columns. And if a variable is missing, use a 0 to hold its place. So if I have something like X plus 2Z equals 5, you see there's no Y, so I would make this a 1 for X. There's no Y, so I put a 0 in for Y, a 2 for Z, and a 5, right? So whatever's missing, put a 0 in. All right. Okay, so the idea is first we have to make sure our algebra is good. We got to put them in standard form. So with standard form, what I want to have is the X, Y, and Z on one side and the number on the other. Okay, and she said she wants A to be positive. That's just typical. Okay, so I want X to be positive and the rest of them can be whatever. So when I look at this equation, I'm going to move the X over to make it positive. So I'm going to plus X to both sides. And I end up with X plus 2Y equals 3Z. The one thing I want you guys to keep in mind, for me to move that X over to the other side, the only thing I'm doing is changing its sign. All right. So if I look at this, I want to move the 3Z over. So I'm going to minus 3Z on both sides. And I end up with X plus 2Y minus 3Z minus 4 equals 0. Okay. And I want to get the 4 over on the right-hand side, so I'm going to add 4. So I get X plus 2Y minus 3Z equals 4. And there's my equation, right? I've got it. Sorry, let me write it up here. X plus 2Y minus 3Z equals 4. So I'm just going to put 1, 2, it's 1, 2, negative 3, 4, right? Okay, so those are the coefficients that I would put in that first row, okay? You don't have to go through all this algebra though. I mean, honestly, it's, you know, when you change the side, a negative becomes positive and a positive becomes negative. So when you change sides in an equation, you just have to change the signs. So for example, if I look at this guy, there's a negative 8x. I'd like to move him over to the left-hand side. So I'm going to do that, but I'm going to make him positive. So it's 8x. And I have a minus 3y. I'll keep that there. Now the 5z is positive, and I would like to move him over, so I'm going to make him a negative 5z. See how when I move the sign, when I move the thing to the other side, I change its sign. And then I have a 7 on the right that I would like to be on the left. Here, let's do that in different color. So the positive 7 is going to move over here and become a negative 7. All right. So if it's a positive, it becomes negative. It's a negative, it becomes positive. All right, and that's my equation. So 8. Negative 3, negative 5, negative 7 is what I put in the matrix. All right, let's take a look. All right, so you have to be in order X, Y, Z. So I'm going to put the X term first. I'm going to go negative 5X. I have to move the Y over, so a positive Y becomes a negative Y. That's negative Y. 9Z would come next. And then I have left over, I have a negative 8. Please keep the negative with it, right? It didn't go anywhere. So there's your equation. Oh, no, she wants the first one positive, doesn't she? Right? Okay, if she wants A to be positive, you know how I can fix that real quick? I just multiply them all by negative 1. So I'm going to multiply this whole equation by negative 1. And I get 5, just changing all the signs, 5x plus y minus 9z equals 8. So there. Okay, now my lead term's positive. 5, 1, negative 9. Uh-oh. Yeah, 8. Okay, this next one, you see that there's no y. When there's no y, you're going to put a 0. It's plus 0y. All right, when something's missing, put a 0 there. Minus z equals 6. So all I had to do there was add a 0 for the y. So I have 2 for x, 0 for y, negative 1 for z, and 6 for the answer. So this next one, I'm gonna move everything this way because x is positive. So I'm gonna move the minus 7y over, so it becomes a plus 7y. Move the negative 4z over, so it becomes negative 4z. I have nothing left over there, so it's 0. 1, 7, negative 4, 0. Okay, you always put them in alphabetical order, X, Y, Z, answer. Is this okay? Any questions about what I'm doing, or are you good? Good? All right. So what we do with these is we make an augmented matrix. So again, to make an augmented matrix, it has to happen in alphabetical order, lined up, and it has to have the answers on the other side. So if I look at these equations, I'm going to fix them first. So 4x plus 6y minus 3z equals 30. Let's see, negative 2x comes first. Okay, I got to move the 5y over, so it's minus 5y plus 7z. And the 20 has to come over, so it's going to become negative 20. Right? Now, oh, I goofed again. A has to be positive, right? Is the first term positive? No, so I got to fix it, right? So what I'm going to do real quick, I'm going to change all the signs. So make this positive, positive, negative, positive. See, I just changed all the signs over here. I multiplied by negative 1. All right, so I guess I'll move stuff this way because x is negative. So if I move x over, it becomes positive x. Moving y over, it becomes negative y. Keeping the 9z. I'm not moving 40. Oops, that's a z. All right, so is that right? Let's see, x minus y, 9z, yeah, negative 40. So x minus y plus 9z. Now, once you have them lined up like this, x, y, z on one side and the numbers on the other, super easy to write the matrix. You're just making a matrix out of all the coefficients. So I just write a matrix 4, 6, negative 3, 30. 2, 5, negative 7, 20. 1, negative 1, what is this, 9? And negative 40. All right, so this would be the augmented matrix. You can put that line there if you'd like, but it's really not necessary. Okay. All right, is that all right? So I have to line them up. That's the bottom line here. Let's do. I really need to get to that. Let me do X, Y, Z. Let's do number 3. I'm going to skip number 2. It's kind of the same thing. So I'm going to lay these out. So I'm going to move the 3x over. So it becomes a positive 3x. There's no y, so I put a 0y. Move the 8z over, so it becomes minus 8z. And I'm moving to the right, so the 2 needs to go to the left, so it becomes a negative 2. Variables on one side, number on the other. And I'm going to move the x over, so it becomes a positive x. Y gets moved over, so it's minus y. And there's no z, so I put 0z. 0z. And the answer is 1. Now, 1's got to get moved away from where I moved. This is going to be a negative 1. Okay, numbers on one side, variables on the other. All right, and one more to go. All right, I have 0x plus 6y minus 4z. That's pretty straightforward, equals 0. All right, so now we can just write the matrix. 3, 0, negative 8, negative 2, 1, negative 1, 0, negative 1, 0, 6, negative 4, 0. All right, and there's my augmented matrix. Okay. So when you're writing these augmented matrices, you must put them in alphabetical order. You must line them up X, Y, Z, and answer. That's the bottom line. Because what you're going to be doing are some word problems, and you have to manipulate them to put them in that form. All right. That's okay?
Yes, ma'am.
Okay. So we're going to talk about simplex before I get into the notes. All right. Simplex is a business method. It's a business math for maximizing or minimizing something. You guys only deal with maximizing. Usually you want to maximize your profit or you want to maximize your revenue. I mean, as a business owner, that's the reality of it. Okay. There are things we have to talk about. When I make a cake, all right, I need eggs, sugar, milk. Let's just say and flour, right? That should be about it. All right. So I need 4 ingredients. Those are what we call resources. That's what I'm using to make my cakes, okay? And if I have 10 cups of flour and I'll make my cakes and I've used 8 cups and I have some left over, I have 2 cups left over, that's called the slack variable. So a slack variable is after you've made everything and you've maximized your profit, it's whatever you have left over that you haven't used, okay? So if I make my cakes, I may have some leftover flour, leftover eggs, leftover sugar. What else did I say? And milk, right? So I could have any of those amounts left over depending on what it took to maximize. All right. Sometimes you won't have anything left over. All right. So a slack variable, when she talks about it, is what you have left over after you made everything. Okay. It's what resources, what you have, what you've used, what I got left over. So we're going to look at some actual practical problems so you can kind of get that idea before you start doing this in simplex. All right. So I am going to change just one little thing. I'm going to make this just to match with what they do. I'm going to call this x1, this variable, and I'm going to call this x2. Okay. And that'll match with what you see when you get to simplex. All right, so let's read this problem. There's a problem. No? Yes. Maybe not. All right, so we have a table here. All right. And pretty much, I mean, you can see what it is. I have the price of a pizza. It's $6, obviously. And this is the number I'm buying. All right, and I have total I spent on pizza. The price of the soda is $2, and this is the number I'm buying. And then there's a total. So I want to know how much I spent. Now I have $68 available to myself. That's my budget. Okay. So we're going to work through some just practical problems. All right, so if I have 3 pizzas and they're $6 each, I'm spending $18. I'm doing 3 times 6 on pizza, right? All right, if I buy 12 sodas at $2, 2 times 12 is 24, right? So the total amount of money I spent would be 18 plus 24. It's the pizza money plus the soda money. So I'm going to do that in my calculator real quick. So I spent $42, right? But I had 68 available. So if I take 68 minus 42, the leftover amount would be $26. That's my slack variable. That's how much money, in this case, it's money is my resource. I have leftover money. I have $26 left over. Okay. So the slack variable is the leftover. And this is what they call the slack. All right, so we do another one. If I do 4 pizzas for $6, well, 4 times 6 is 24, so that's going to cost me $24. And if I buy 16 sodas for $2 each, $32 on sodas. So if I add those together, that's the money I spent. 32 plus 24, I spent $56. All right, so the money I've left over, if I have a budget of 68, I do 68 minus 56. And I'm doing my calculator. I have $12 left over. Okay, so depending on what I spend, I'm going to have some money left over. That's my slack variable. All right, so let's do a couple more. 6 times, if I buy 5 pizzas, 5 times 6 is 30. 16 times 2 is 32. So that's how much I spent for soda. So 30 plus 32 is 62 bucks. I had a budget of 68. So 68 minus, I have $6 left over, okay? All right, so you see that varies depending on how much I spent. All right, so fill this last one. 5 pizzas would be 30 bucks. 18 sodas. Well, times $2 each. So I'm spending $36 on soda. 30 and 36 is 66 total. And then I have $2 left over. Okay, is that all right? All right, now we're going to put it in terms of X1 and X2 rather than X and Y, all right? So if I buy X1 pizzas, the total price for the pizzas would be 6 times the number of pizzas, which I called X1. Is that okay? No, I'm just making it fair. All right, the money I spent on soda would be 2 times X2, right? It's just $2 times the number of pizzas, number of sodas I bought. So the total spent would be the sum of these guys. So it's 6x1 plus 2x2. That would be the total amount of money I spent. All right. So now we go down and look at the problem. Write an expression representing the amount of money Jerry will spend on, I'm going to call this X1 pizzas and X2 drinks. So that's pretty much this right here. So it's $6 per pizza plus $2 per soda. That's the total amount of money he's spending. Is that all right? Now, to stay under budget, I've got $68 available, so that money better be less than or equal to 68. So the inequality is 6x1 plus 2x2 is less than or equal to 68. Okay. Now, when you get to simplex tableau, you must turn the inequalities into equalities by adding slack variables. All right. So slack variable is the leftover amount. We call it S. That's the leftover. So to turn it into an equality, if I take the money I spent, which would be this, and I add the leftover, which I call S, it better equal 68, right? That's the total amount of money I had. All right. So you want to think of slack variables as leftover. In this case, it's leftover money. All right. It takes up the slack. All right. You add that to make it from an inequality to an equality. It's what I have to add to make it equal. All right, so this is what we mean by a slack variable. It's what's left over. Okay. All right, you good so far? All right, so we're going to do another one of these, but not all of it. And then I need to get down here. All right, so it says Judy's buying, I'm going to call this X1 just to match what you're going to be doing. X1 number of pogo sticks and X2 number of hula hoops for a party. Pogo sticks cost $20 each. Hula hoops cost $10 each. Her budget for the items is $500, so she can't exceed $500. All right. So they have a little column here, and we're going to do the same thing we did above. So the price of a pogo stick is $20. If I buy 8 of them, I do 8 times 20. I'm going to spend $160 on pogo sticks. My daughter wanted one for Christmas, like an adult one. Do you know how much an adult pogo stick costs? About $400. I was like, well, not for me. I was like, no, I don't. All right. Anyways, price of a hula hoop, $10. 15 hula hoops. 15 times 10 is $150. All right. So I spent $150 on hula hoops. The total I spent, just add them up, 160 plus 150. It's going to be 310. And the leftover amount. So the leftover is the money I have left over. So I had 500 available and I spent 310. So I do 500 minus 310. I get 190. Okay, so that's the money I have left over. All right, that's my slack variable. My slack variable is what I have left over. All right, we're going to do one more of these, and we'll set up the equation. So this, I'm going to call this X1, and I'm going to call this Y1. All right, so we'll just do this one. So if I have 12 pogo sticks times $20, it's going to be $240. And if I buy 24 hula hoops at $10, 24 times 10 is $240. So if I add those together, I spent $480. out of 500, so I got $20 left over, all right? So my slack variable is what I have left over, all right? So with variables, the cost of pogo sticks would be 20 times the number I buy, which I'm calling X1. I'm gonna call this X2, I'm sorry. All right, the cost of a hula hoop would be 10 times X2. So the totals I spent would be 20X1 plus 10X2. That would be the total money. All right. All right, write an expression representing the amount of, we're going to call this X1 and X2. So write an expression representing the amount of money Judy will spend on X1 pogo sticks and X2 hula hoops. That's this right here. So it's 20X1 plus 10X2. Okay. Then write an inequality expressing the money to stay under budget. So I know that the total money has to be less than or equal to 500. So I simply write 20X1 plus 10X2 has to be less than or equal to 500. Now, I'm going to let S be the leftovers, the slack variable. Write an equation expressing the money that adds up to 500. So for it to equal 500, I take what I spent, which would be this, plus my leftovers, which I'm calling S, and set it equal to 500. So the slack is what I have to add to turn it into an equality. It's my leftover. Is that okay? All right, so. This one I'm not going to do with. It's the next one I need to do it. All right. So these word problems you're going to get, the simplex tableau word problems, this is not all of what you'll see, but it'll be part of it. Part of it is setting up what they call constraints. A constraint is an inequality. If I'm using sugar, I only have 5 cups available, sugar available, so it's going to be less than or equal to 5, right? So a constraint is an inequality. It's based on what I have. There's an objective is what you want to find the maximum of. Most of the time, it's a business person, it's you want to maximize your profit, all right? So you're not going to see me setting up an objective today, but it's there. But we're going to set up some constraints, is what we're going to do. All right, so it says, write an inequality. So Ralph is planting, I'm going to call this X1 acres of corn and X2 acres of wheat. He owns 180 acres, although he won't necessarily plant it all. All right. So if I want to write the inequality, so he's going to plant a total of X1 plus X2 acres, right? That's what he's planting. And how many acres do I have available? 180. Right, so that has to be less than or equal to 180, right? Because he may not plant them all. So that's what we call a constraint. It's an inequality, all right? So now what we're going to do is we are going to add slack variables, all right? A slack variable, you're going to have, I'm going to let S1 equal the leftover acreage. All right, or I'll just call it S because there's something there. All right, so I basically do X1 plus X2 plus the leftover acreage has to equal 180. All right, so we add the leftovers and turn it into an inequality. All right. So this is more common sense, this problem, then we'll get into something that I really want to show you. All right, so 50 acres of corn, 70 acres of wheat, how much leftover will we have? So this is really common sense. If I plant 50 acres of corn and 70 acres of wheat, I planted total 120 acres, right? But I had 180 available, so what's left over? How many acres did I plant? That's basically it. So I planted 120 out of 180, so what do I have left?
40.
60, right? I have 60 acres. I just take the total minus what I planted, right? So if I do 180 minus 120, I have 60 unused acres. Okay, so that would be my slack variable. It's what I have left over. Same thing, if I plant 60 acres of corn and 90 acres of wheat, if I do 60 plus 90, that would be 150. So it's left over, my total 180, so it's 180 minus 150. And I'm going to have 30 acres left over, right? All right, that I didn't use. That's a slack. That's what I'm not using. Okay. All right. This particular type of problem, my suggestion to you is to make a table, okay? What I do with Simplex Tableau, I make myself a little table. I do what I'm making goes up here with a total. And what I'm using to make it goes down here. This is what I'm using, okay? And it just helps me read things, all right? So I'm going to go through this problem. I'm going to read it first. Chloe makes 2 kinds of fruit basket. For fruit basket type A, she uses 4 apples and 5 oranges. For fruit basket type B, she uses 6 apples and 3 oranges. She only has 8 baskets, 52 apples and 36 oranges. All right, so what I'm going to do is make myself a little table. So she's making 2 types of baskets. We'll call them A and B. All right, and we'll call this one X1 and this one X2. All right, and we're going to have a total column. What is she using to make the baskets? Well, she's using apples, right, and oranges, and she's also using baskets, right? Those are her resources. That goes down on the rows, okay? Apples, oranges, baskets. Now I'm going to fill the table in with numbers. All right, so for fruit basket type A, she uses 4 apples, that goes there, 5 oranges, right? For fruit basket type B, she uses 6 apples and 3 oranges. She only has, those are total, here's my total. All right, I have 8 baskets, 52 apples, and 36 oranges. All right, so now I kind of have it organized in a way in which I can read it. Okay, so let's do this. All right, so first we're going to do some numbers. All right. So basically, if I were to read across this row, the number of apples I use, just read across the row, would be 4x1 or A plus 6x2 or B, right? And I know that that has to be less than or equal to 52. See, I'm getting my constraints here just by reading across the rows. That's why it's nice to set up tables. The oranges would be 5x1 plus 3x2, and that's less than or equal to its total, right? Now I got nothing for baskets, but it's just x1 plus x2, and there's nothing there. So I know that x1 plus x2 is less than or equal to 8. So these things right here are what they call constraints. Okay, they're my inequalities, all right? So I want you to notice I am using 3 things to make these baskets, apples, and oranges. So I'm gonna have 3 slack variables, one for the leftover apples, one for the leftover oranges, and one for the leftover baskets. So when I work with Simplex Tableau, you have 3 types of leftovers. All right, so let's do some numbers. So if I do 4 of type A and 3 of type B, so I want to know baskets. So baskets, I did 4 baskets for A and 3 baskets for B. So she's going to use 7 baskets, but she had 8 available, so she's going to have 1 left over. Okay, is that all right? Yeah. Okay, so the apples. So she uses 4 apples for type A. So type A, she's making 4 of them. And she uses how many apples for type B? It's 6. And she's doing 3 of those, right? And so that's the number of apples she would use. So I'm going to plug it in a calculator. 4 times 4. I got a total of 34 apples. But notice we have 52 available. So if I do 52 minus 34, that's the leftover. We get 18. Okay. And the oranges. So the oranges, I use 5 for basket and 4 basket A's. And I use 3 oranges and 3 basket B's. So let's see what happens there. That's going to work out to be 29. And I have 36 available, so 36 minus 29 is 7, so that would be my leftover oranges. Okay, so I'm just trying to get in your head right now. A slack variable is what I got left over of everything that I'm using to make whatever the heck I'm making. Okay. Everybody good? Can I go on or? Yeah? No? Still writing? It really scares me when you guys don't respond. Yes, I can go on. No, I can't. Yes, okay. All right, so in general.
Professor, do you have permission to leave early? I have to go to work.
That's fine. All right. Make sure you watch the rest of this, okay? When you guys get to Simplex Tableau, you might want to go back and watch this because, okay, it'll.
Did you ever get my name down for attendance?
Yeah, I saw you were here. I fixed it. I will fix it. I saw it.
Thank you.
Sure. Okay, so we're going to write these as if they're constraints, all right? So basically, I'm going to assume that I'm making X1 baskets of A and X2 baskets of B. I changed them to X1 and X2 because you guys are going to be using those for variables. All right, so the number of baskets she will use is simply, if I go back to this table, it's X1 plus X2. So I want to write an inequality. So I know that the number of baskets, go back up to your table, is less than or equal to 8. So I want to turn that inequality, that constraint, into an inequality by adding the leftovers, right? So the way that you do this is you say, well, X1 plus X2 plus a slack variable, I'm going to call that S1 equals 8. Now I'm going to ask you, what does S1 represent? It's a slack variable. Physically, what is it?
Leftover.
It's leftover what? Is it baskets, apples, or oranges? Baskets. So for each different resource, you're going to introduce a different slack variable, okay? So now we're going to do another one, the number of apples. So the number of apples, I'm just going to read across, it's 4x1 plus 6x2 is less than 52. So I can just read across the table. This is why I like tables, because you can just read straight across. So now I'm going to introduce another slack variable, which is now the leftover apples. I'm going to call it S2. All right. So what I'm going to say is 4x1 plus 6x2 plus S2 is equal to 52. So S1 is leftover baskets. S2 is the leftover apples. And I got one more to do. I got to do oranges. So I go up to my table. I've got 5x1 plus 3x2 is less than 36. So I can just read across. Oh, I forgot it already. 3x2. So now I'm going to introduce another slack variable called S3. That's leftover oranges, right? So I would set this up as 5x1 plus 3x2 plus the leftover oranges, which are called S3, equals 36, all right? So this is the leftover oranges. Okay, so for each resource you use in these problems, you introduce a different slack variable, okay? And that'll help you set these up. Okay, so right now, all I'm doing is setting up what they call constraints. We haven't talked about how to solve them, what it means, just this is how you set up the constraints. All right. I'm going to skip number 5 just because I'm running out of time. I need to get to talk about these matrices. All right. I'll probably put a solved, when you guys get to it, I'll put a solved simplex problem up as a video, just so you can see me solving one. All right. So once you write, you're going to use that information to write something called the augmented matrix, all right, and you're going to work this program. You're either going to work with the calculator called Simplex, or you're going to work with it on a website online, depending on what you choose, all right? Now, we want to get to the point, well, I won't talk about that. First of all, let's talk about identity column is a column that has a 1 in all zeros. So if I look at that, those 2 columns I circled are identity columns. The other guys are not, okay? I'm going to be interested in identities because those give me the non-zero answers. So if I look at this matrix, there's an identity column. See how it's all zeros and 1, 1? Those are identity columns, all right? It's not going to have a lot of meaning until you get to simplex. This one is identity. Oh, here's 1, and there's 1, right? Those are identity columns. See how they're all zeros and 1, 1. It's okay if I skip the other two because it's the same thing. All right, now to solve two simplex town blue, you're going to use this program and you're going to have to pick a pivot. Now, I haven't talked to you what the bottom row is something a little different. It's your objective, all right? And what's going to happen, you see these are all negatives with a 1 there. That's going to happen on your bottom row of your matrix. The top row is all these constraints we've been writing, okay? The bottom row is something else. But you're going to pick what they call a pivot point. A pivot point is going to help you find the maximum. And basically what you do is you go down here and you look at the bottom row, all right? And you are going to find the number on the bottom that is the most negative. All right, so if I look at this, the most negative number is -9. That's my pivot column. All right, so this is what we call the pivot column. It's the most negative on the bottom, only on the bottom. We're only looking at the bottom row. All right, so if I look at this guy, you guys tell me what column would be the pivot column. So look here. What column has the most negative number in the bottom row? The second one. So this is your pivot column, right? Okay. Here, I would look at the bottom, -16, right? I pick the one with the most negative number. Now, what's going to happen is you're going to run this program and you're going to get new numbers on the bottom. And you always keep picking the most negative number until you have no negatives left in the bottom. Okay? Then you're done. Okay? Pick the most negative number. Now you're going to pick something called the pivot row. You don't know what it is yet. This is an incomplete thing, but you're going to find the most negative row, circle that column, right? Now, to find the pivot row, you're going to take each entry in the far right column and divide by the corresponding entry in the circle column. Do not use the bottom row. The bottom row is different, all right? So you want to look at all the quotients. They have to be positive, no negatives, and identify the smallest positive quotient. So what I'm trying to tell you, let's talk about how to do this. So when I look at this problem here, I usually put a line here so I remember they're different. The most negative number occurs here, right? So that would be my pivot column, okay? So then I'm going to take the last number, which is 37. I'm going to divide it by 7, okay? Then I'm going to take the last number up here, which is 42, and I'm going to divide it by 8. So I'm going to do each of those on a calculator. I don't consider the bottom row. That's different. So I get 5.25 for this quotient, and I get 5.285. So I want to pick the one that's smaller. So which one? The one that's smaller is the 5.25. So the smaller one, this is the pivot row. So you pick the smaller one. So in that program, we want the pivot row is row 1, and the pivot column would be what? 1, 2, the third column. Okay, and that's how you're going to tell that program on that website how to pivot. All right. Once you know what a pivot is. All right, and you keep repeating this process until all these rows on the bottom aren't negative. Okay. So, and the calculator is going to run its program and spit out another matrix. This is what's going to happen. All right. So let's take a look at this. I have one more to go. Let's do this one. All right. So if I start with this matrix, the most negative number I see is right here, right? -16. Okay. Now, to pick the pivot column, okay, 40 divided by 0 does not exist, so you don't have to worry about it. All right. It's like infinity, so you can ignore it. 28 divided by 3. Plug it in. 9.33. This doesn't exist. And 45 divided by 7, 6.4. So I just divide the last number by its column, and I pick the smallest positive one, which would be this one, right? So here I'm going to pivot on row 1, column 3. Okay. So I don't know when you guys are going to get to this. I'm assuming probably within the next 2 weeks. So I'll put a video up. We solve one of these. Okay. All right. So good luck on your test. Don't forget about your test tomorrow. Okay. Do well. All right. Study the review. Okay. All right. See y'all.